Hi everyone, welcome back to chemistry class here at Brain Charger. So this is lesson number 2 on the topic of redox reactions. So in the previous lesson, we discussed the definitions of oxidation, reduction, and redox reactions. So in this lesson, we are going to focus on oxidation numbers. So at the end of this video, you should be able to explain the term oxidation number, state the rules for assigning oxidation numbers, and also assign oxidation numbers to atoms, ions, and compounds. So let's start by defining oxidation number. What is an oxidation number? So the term oxidation number refers to a numerical value assigned to an atom in chemical compound that reflects its degree of oxidation or reduction. So recall in the previous lesson on the definition of oxidation, we defined oxidation as the process where an atom, molecule, or ion loses one or more electrons. And we define the reduction as the process where an atom, molecule, or an ion gains electrons. So oxidation number, in simple terms, indicates the total number of electrons that an atom has gained, has lost, or shared when forming a compound. So that's oxidation number. So now let's look at the rules which are followed when assigning oxidation numbers. So rule number 1, the oxidation number of an atom in its elemental form is always 0. So what does that mean? When an atom is existing as a free element without combining with another element, the oxidation number of that atom is 0. For instance, we have oxygen. As it is existing as oxygen molecule, as an oxygen molecule in short, the oxidation number is 0. And also the same applies to an element like iron. For it is existing as a free element, iron also has an oxidation number of 0. Rule number 2, the oxidation number of monoatomic ion is equal to its charge. So we have a number of monoatomic ions. For instance, we have sodium ion. So the charge for sodium ion is positive. So the oxidation number of sodium ion is positive 1. The same applies for a monoatomic ion like chloride. So chloride ion has a charge of negative, so the oxidation number equal to -1. So that's how we assign oxidation numbers to monoatomic ion. So the charge equals the oxidation number of monoatomic ions. Another rule is that the oxidation number of oxygen in all compounds is -2. So for instance, in water, oxygen has an oxidation number of -2. But in peroxides, oxygen has an oxidation number of -1. So for instance, we have sodium peroxide. So in sodium peroxide, oxygen has an oxidation number of -1. Another rule, the oxidation number of hydrogen in an ionic compounds is +1. So for instance, in water is an anionic compound, so the oxidation number of hydrogen in an anionic compound like water is +1. But in ionic metal hydrides, the oxidation number of hydrogen is -1. So for instance, in sodium hydride, the oxidation number of hydrogen is -1. So that's another rule for assigning oxidation numbers. So another rule is that in a neutral compound, the sum of all oxidation numbers must equal 0. So we have a number of neutral compounds. For instance, we have water. So when you add the oxidation number of hydrogen atoms and oxidation number of oxygen atom, the sum should be 0. But in a polyatomic ion, the sum of oxidation numbers equals the ion's charge. So for instance, we have nitrate ion. So in a nitrate ion, the oxidation number, okay, we have a charge as negative, so the oxidation state of nitrate ion is -1. So in other words, when you add the oxidation number of nitrogen and the oxidation number of oxygen atoms, the sum should equal -1. So in any polyatomic ion, the sum of oxidation numbers equals the ion's charge. So now let's do some practice problems. Let's try applying the rules and see how they work in a problematic scenario. Okay, so number one, would determine the oxidation states in the following species. So in other words, for every atom in that compound, we should determine its oxidation. So the first compound is dichromate ion. So we have dichromate ion, which is made up of 2 chromium ion atoms and 7 oxygen atoms. So we have 2 chromium atoms and 7 oxygen atoms. So remembering the rules for assigning oxidation state, oxidation numbers, this is a polyatomic ion, okay? So it has a charge of -2. So when we add the oxidation state or the oxidation number of chromium and the oxidation number of oxygen atoms, the sum should equal -2. So what does that mean? So let's say the oxidation state for each chromium atom is X. So X, so we can write, for we have 2 atoms of chromium, so we can write 2X plus, so we can let the oxidation number for oxygen to be Y. So we have 7 atoms of oxygen, meaning to say we will have 7Y. The sum should equal to -2. But also remembering, we have the oxidation number of oxygen as -2 in any compound. So in other words, here the oxidation number, the value of Y is -2. So this is not a peroxide. That's why we are saying that the oxidation number of oxygen should be -2. So we can substitute -2 here where there is Y. So our equation will be 2x plus 7 multiplied by -2 should equal to negative 2. So when we simplify, we get 2x minus 14 should equal to negative 2. And then adding like terms or combining like terms, we get 2x is equal to negative 2 plus 14. So negative 2 plus 14, we have positive 12. So dividing by 2, both sides, we get x is equal to 6. So in other words, the oxidation state, the oxidation number of oxygen in this ion is equal to negative 2, and the oxidation number of chromium in this ion is positive 6. So if we can substitute these values in our formula, we will get negative 2, which is the charge for dichromate ion. So that's how we can handle a question like that. So we have another compound, which is chromic acid, or sometimes it is known as tetraoxochromic acid. So for simple terms, I will be just saying chromic acid. So we need to find the oxidation number of hydrogen, the oxidation number of chromium, and also the oxidation number of oxygen in this compound. So this is a neutral compound. Why am I saying that? The reason is that the charge of this compound is equal to 0. So it's a neutral compound. So remembering our rules for assigning oxidation number, in any neutral compound, the oxidation number of hydrogen is equal to positive 1. So hydrogen has oxidation number of positive 1 in any neutral compound. And also, oxygen has an oxidation state or oxidation number of negative 2. So having known the values of the oxidation number for hydrogen and oxygen, we are remaining to find the oxidation number of chromium atom. So this will be easy. So just a reminder, when we add the oxidation number of hydrogen, chromium, and the oxygen, we should get 0, because this chromic acid is a neutral compound. So let's start solving. So we can let the value of hydrogen oxidation number be x. So we have 2 hydrogen atoms, we have 2x, plus chromium, we can let it to be y, and plus that of oxygen, which can be z. So we have 4 oxygen atoms, 4z equal to 0. So we know the value of x as positive 1. So we will have 2 times positive 1, which is 2, plus the value of chromium oxidation number, we don't know it yet. So we need to find the value of y. So let's just put down the y, plus 4z. The z actually is for oxygen, which is negative 2. So we will multiply 4 by negative 2. So we should get 0. So when we multiply negative 2 by 4, we should get negative 8. So adding negative 8 and 2, positive 2, the overall equation should be y minus 6 is equal to 0. So just taking the negative 6 to the right hand side of the equation, so we get y is equal to positive 6. So in other words, in short, the oxidation state, the oxidation number of chromium in chromic acid is positive 6. So we can just summarize as hydrogen equal to positive 1, chromium positive 6, and oxygen has an oxidation number of negative 2. So the idea here is that when we add the oxidation states of all these atoms in this compound, should equal to 0. So that's how we can actually find or assign oxidation numbers for various atoms in a compound. So our next problem reads, does the oxidation state of phosphorus vary in this compound, and that compound? So this video has actually reached a certain amount of minutes, so I'll give you this problem for you to solve, to practice, and you can actually verify your answer to anyone who you trust that can help you with it. But if I may have time, I will solve it and post it here on the channel, so be sure to check around. So congratulations actually for reaching the end of today's lesson, and in our next lesson we will learn half equations in redox reactions. So until that lesson, my prayer is stay safe.